Hey guys, so today I'm going to be telling you about atmospheric pressure. So, we know that pressure is created when air molecules collide with surfaces. And because we are as well as surface, we have air molecules colliding with us all the time. This is atmospheric pressure. So this is the pressure that the atmosphere is making on us, okay? The atmospheric pressure has a number, is 101 kilopascal at sea level. Now, kilopascal is 10 to the power of 3 Pascal, okay? So that's 100,000 Pascal or then 101,000 Pascal, okay? Now, what happens is, let me just say something. So you have the atmospheric pressure, right? So you should be thinking right now that the pressure outside your body is pretty high and not understanding how you are not imploding or feeling that pressure, right? The reason for that is because the pressure in your body, due to your blood flowing into your veins, equates that pressure, so balances out. So your pressure is also going to be around 100 kilopascal, and this is why you do not feel the atmospheric pressure. And this is not why you're not imploding or exploding, okay? Now, atmospheric pressure, just like depth, when we spoke last video, and I told you that as you go deeper and deeper, the pressure increases because you have more particles above the particles that are in that depth where you're studying. The same happens with atmospheric pressure, but the other way around. As you increase your altitude, the density of the atmosphere decreases because you don't have as many particles in a certain amount of volume. Then you're not going to have as much force per unit of area. Therefore, the atmospheric pressure is different to 100 kilopascal at sea level. It decreases, and the pressure decreases with altitude. The more you increase in altitude, the more the pressure decreases because, again, you have less particles above you. Now, we can use atmospheric pressure for everyday life stuff, like rubber suction cups and straws. So the rubber suction cups, they work because you get a vacuum in between. So when you do the suction part, you get a vacuum in between the two cups. So the pressure outside the cups is much larger than inside the cups, and therefore is almost impossible for you to open the cups or to separate them. That's why you can use them, and people can use them to climb and all these things, surfaces. And the straws is thinking about what we learn about the pressure in liquids. So again, you get a vacuum when you're trying to suck in your straw. So you create a vacuum inside your mouth. So you know that the liquid is going to level up at the same pressure. Suddenly, the side that is on the straw has a much lower pressure than the side outside the straw that has the atmospheric pressure. So the liquid goes up the straw to try to go up to a level where it can equate the other pressure, the pressure outside the straw, so the pressure in the glass, for example, on the surface or the liquid in the glass. So that is why you can drink from straws, okay? However, the most important part of this slide is that the density of the atmosphere decreases with increasing altitude, therefore the pressure decreases with altitude, okay? Now, atmospheric pressure, as I told you, decreases with altitude because there are less air particles above a given altitude than there are at a lower altitude. And again, remember, pressure is force over area, less particles, each particle has a certain amount of force, but because I have less overall, I have less force into the same space or surface area, therefore the atmospheric pressure decreases with altitude. Now, this has implications, and one of the most known implications are the implications when someone tried to climb the Mount Everest, where you need to be quite careful and quite fit, plus bringing some oxygen bottles. Actually, I think someone was able to do the climbing, not the going down, but the climbing without the oxygen bottle, but I'm not sure if he's up to the very top, okay? But normally a common person cannot climb Mount Everest without oxygen, and this is because after a certain altitude, which is 8,000 meters, about 22,247 feet, you do not have enough oxygen for you to breathe, and there are a lot of problems that are going to come from that, from disorientation, your cells not respiring, all these things, okay? I have two videos about this, okay? So in the Mount Everest, you have this death zone, which is the name used by mountain climbers for the high altitudes where there is not oxygen for the humans to breathe. Again, this altitude is about 8,000 meters high, or up, or above the sea level, and most of the over 200 climbers that have died in Mount Everest have died in the death zone. To add to that, when someone has an issue in the Mount Everest, it's very rare for people to be able to help them, because they know that when someone is going to help them, they may die. And many of the bodies are actually left behind in the Mount Everest because it's such a difficult rescue mission to get the bodies out. Again, even if the person is dead, they don't want to risk the lives of the rescuers to try to take that person, because the rescuers themselves, they can die. Because there are so many bodies in Mount Everest, some of the bodies are actually used as landmarks for other climbers. So they say, oh, we got to the green boot, so we are at this point in the map, for example, or this point in the height, in the climb. So I have two videos for you. The one on the top is, I believe, is a longer one. Is kind of, it can be quite heavy for you, but it's important for you to understand the consequences of atmospheric pressure. And the second one is an interview about recent deaths. So they are talking with a climber that has gone up the Mount Everest several times, and then he's just talking about common things that can happen, okay? So that's on atmospheric pressure and altitude. So remember, atmospheric pressure decreases with altitude, and pressure increases with depth, okay? Now, imagine that I want to calculate pressure difference, or that I want to calculate the force on a flat object due to the pressure difference. So I have the object at one place, I have the object at another place, and there are some differences in the pressure, something that is going to be important for you later on. I want to know the force on this object. So the force will be the pressure times the area. And this comes from the pressure formula. You know that pressure equals force over area, therefore force equals pressure times area. Force is the force on the flat surface in newtons, and P is the pressure difference in Pascal, or PA, or Newton per meter squared, or Newton meter minus 1. And A is the surface area of the flat surface in meters squared, or meters 2. Okay, so I was just reading as it said in there. And you might not see why this formula is important right now, but you're going to see very, very soon, okay? But that's going to be in a different video. So up to my next video, I hope this lesson made sense. Up to my next video, and we using this formula as well for floating and upthrust. I hope everything goes well, so be happy and healthy. Bye!